Hello everyone, welcome back to my channel. In today's video, I'm going to test this power drill after it has been sitting in use for a long time. But as you can see, even after pressing the power switch multiple times, the drill does not respond at all. Instead of throwing it away, I want to check whether this drill can still be repaired and brought back to life. First, I remove the drill battery to inspect the power source separately. Then, I use the original charger to try charging the battery again. But as you can see, the indicator light on the charger does not change color like it normally should, suggesting that the battery may have a problem. Next, I try another method to test the battery. I attach two metal washers onto the battery contact slots to create temporary electrical connection points. Then, I connect the wires from a cooling fan onto these washers to check whether the battery can still provide power. But as you can see, the cooling fan does not work at all. To confirm further, I connect the cooling fan directly to the charger, and the fan immediately starts spinning normally. This clearly shows that the issue is coming from the battery itself rather than the testing device. Next, I use a multimeter to measure the voltage of the battery. When I place the multimeter probes onto the battery terminals, the display only shows zeros. This indicates that the battery is either completely drained or its internal protection circuit has shut down. First, I place a piece of tape onto the surface of the battery. I use a marker to draw an X on the tape so the battery can be easily identified during the inspection and repair process. Next, I remove the outer casing of the battery to inspect the internal condition. And as you can see, the internal components still appear to be in good condition with no obvious signs of burning or severe damage. However, there's quite a lot of dust buildup around the circuit board and electronic components. First, I use a toothbrush to scrub away the dust and dirt. Cleaning the board helps improve visibility and makes it easier to inspect the electronic components during troubleshooting. Let me know where you are watching this video from. Don't forget to comment the country you are currently living in down below. I'm really curious to see which parts of the world my videos are being watched from. Next, I use a multimeter to check the solder joints and electrical connection points on the battery circuit board. I touch the probes to several different solder points, but as you can see, the multimeter still only displays zeros. This indicates that electrical current is still not flowing through the battery system. In the next step, I use RP7 spray to clean the electronic circuit board inside the battery. First, I spray a small amount of the solution into a bottle cap to make the cleaning process easier to control. Then, I dip a cotton swab into the RP7 solution and carefully clean around the small electronic components on the circuit board to remove dirt and oxidation buildup. Next, I continue spraying the solution into the battery contact slots to clean the electrical connection area. To clean deeper inside the narrow contact gaps, I use a small piece of sandpaper to gently polish the contact surfaces, helping remove oxidation and improve electrical conductivity. Here I have an old charger, and I'm going to reuse it to create a temporary charging cable in an attempt to revive this battery. First, I use pliers to strip off the outer insulation of the charging cable. Inside, there are 4 small wires, but I only keep the red and black wires while cutting away the white and green wires since they are not needed. Next, I strip a small section from the ends of the red and black wires to expose the copper cores inside. Then, I twist the copper strands into separate branches and connect them to metal washers to create electrical connection terminals. I repeat the same process for the black wire as well. Before connecting it to the battery, I use a multimeter to check the output voltage of the charger. When I touch the probes to the 2 metal washers, the multimeter displays around 6.07 V. This shows that the charger is still working and can be used as a temporary power source for testing the battery. Before supplying power, I carefully identify the battery polarity to avoid incorrect connections. The black charging wire is connected to the negative terminal of the battery, while the red wire is connected to the positive terminal. After making the connection, I begin supplying temporary power to the battery. This method can help reactivate batteries whose voltage has dropped too low for a normal charger to recognize. After about 15 minutes of temporary power supply, I disconnect the charging wires from the battery. Now I begin reassembling the battery back to its original condition. Once finished, I connect the battery to the charger again to see whether the recovery process was successful. After about 20 minutes, the charger indicator changes to green. I press the battery level button, and all 4 indicator bars light up completely. This shows that the battery has recovered quite well after the repair process. To test in real use, I reconnect the cooling fan from earlier. As soon as I attach the fan wires to the 2 metal washers on the battery, the fan immediately starts spinning again. This proves that the battery is now able to supply power normally once more. Instead of throwing away batteries that seem completely dead, you can actually try restoring them using simple methods like the one shown in this video. This not only helps save money, but also allows you to reuse old devices more effectively. If you found this video helpful, don't forget to leave a like and subscribe to support the channel. Thanks for watching, and I'll see you again in the next DIY videos.